Okay, hello. What I'm going to do is we talk about section 1.1 and 1.2. Okay, so we're working on the solving the system of the equation. So we talk about augmented matrix, and we give you the situation that you can change a matrix into easier form. We can reduce it to the row echelon form, or just reduce echelon form. So the application is going to be, if a system of the equation is given to and you want to solve the system, you can focus on the augmented matrix. Okay, so you simplify augmented matrix into the either row echelon form or row reduced echelon form in order to solve the system of the equation. So these techniques, method of the solution, is going to be call it elimination method, like the one in algebra. So if you reduce your augmented matrix into the only a row echelon form and solve the system, this method is going to be called the Gauss method. But if you continue and change it into the reduced echelon form, then it's going to be called, Jordan elimination method. So altogether, they call it Gauss-Jordan elimination method. So simply we refer to that as an elimination method. Okay, so we're not going to distinguish between these two together. So you should be able to solve a couple of these system of the equation for us. Okay, solving so-called elimination method. It doesn't matter. You can use the row echelon form or row reduced echelon form. So I'm going to give you a couple of examples how we're going to apply this method, because most of the examples on 1.2 would be dealing with this type of problems. So now that we got the first week out, so by the end of this week, you should be able to do all the problems in 1.1 and 1.2. Okay, I will post a practice quiz for you. This is going to be for the coming quiz, which is going to be, I'll double check it again, next week. Okay, I think it's a week on Tuesday. Maybe, yes, a week on Monday. I double check it on the syllabus. So I put those practice one and tell you that okay, what type of assignment is going to be due. So let's get this one done, then I'll give you more of this information. So I'm going to go to my camera. And again, if you have any question, you can email me or you can come to my office hour. But before coming to the office hour, just, the time that I gave you or other times you would like, just send me an email that you are coming so that I'll be ready in the office hour. Okay, so this is the method that I talk about it, 1.2. It's the Gauss-Jordan elimination method. So basically we change the augmented matrix of a system into the row echelon form or reduce row echelon form, and then we do the solutions. So there you are. So this is going to be example, and you will get one from each on your next quiz. This is going to be our expectation at the end of this week. These 4 problems, you should be able to solve it for us. So we would like you to solve each system. I simply say by elimination method. Elimination method, or just by elimination. So it doesn't matter. You can use either one. Okay, go as far as the row echelon form or otherwise, we don't mind. Even for the problem in your book, you can do either one. Okay, there are going to be kind of 4 different types. So what's going to be the first one? Let's try this one first, just ordinary one, nothing special. So the system is x minus 2y. Okay, x minus 2y plus 3z. 3z equal to the 9. That's the first equation. The second one is negative x plus 3y. Negative x plus 3y equal to the negative 4. And the third system is 2x 2x minus 5y plus 5z, 5z equal to the 70. Okay, so this is the system that we are going to solve. So the solution, you are going to form your augmented matrix of the system. Remember, this is it. The augmented matrix is going to be, you are going to have the column of the x. Okay, so this is it. The coefficients are 1, -2, 3, and then you have a constant term of 9. The second one, the x is a -1. Okay, the x is going to be -1, the y is 3. There is no z, it's going to be 0, and the constant term is -4. And the third one, we get the 2, -5. Okay, -5, 5, and 17. So this is it. You may remind yourself, you know it, just remind yourself this is the augmented matrix, and this would refer to the x, refer to the y, and refer to the z. That's it. So what we're going to do, you're going to change it to the reduce it. For the reduction, we need the 1 at the first, the non-zero number. You already got the 1. So you have to change this into the 0. So to change this one into the 0, so what you're going to do is, this is the row 2. So we are going to add it to the row 1. Okay, so that's going to be R2 plus R1. So that gives you 0, and you can do at the same time, this is going to be R2. So you can change the R2 into the R2, for example. Okay, twice of the one on the second one, doesn't matter. So I go with the first one minus twice of the first one. Okay, at the same time, we take care of it. So this is going to be the result. So the result is going to be, the first one is going to be unchanged. It's 1, -2, 3, and 9. The second one, R2 plus R1, just add them together, get the 0. Okay, these two together, that give you 1. These two together, that give you 3. And these together, that give you 5. Okay, and this one, R2 minus twice of the R1, 2 times the first one, so it's going to be 2 minus 2, which is equal to the 0. Okay, twice, that give you 4. You subtract it, that give you a negative. Okay, so this is going to be R2 minus 2R1. So if you multiply by -2 times -2 would be 4. So that give you, okay, that give you a -1. And over here we get the -6. So we have a -1 again. Okay, 2R1, that's going to be 18. And this would be -1 again. So that's going to be the second part. Okay, we don't write equal to, we can write equivalent, or just keep going. So that would be the second part. Then, so what we are taking care of the first column, 1, 0, 0. Okay, so we need the second part. The second part, we need the 1 here. You already got the 1, so you have to make the top and the bottom 0. Okay, to make this one into the 0, so I have the, I have the R1. So add it to the twice of the R2. So that would, -2 would disappear. You have to make this one into the 0. So you can add it. So the R3, you can have the R3 plus R2. Okay, so the leftover is going to be, this is it. This is going to be 1 twice of the R2. Twice of the R2, that make it into the 0. Okay, that's going to be 6 and 9. 6, 9, and 10 and 9 would be 19. Okay, 19. Then the second one is going to be unchanged, 0, 1, 3, 5. Okay, and the last one, R3 plus R2. So that would be 0, 0, 2, and 4. There you are. So we took care of the second column. Okay, the second column. So we are going to take care of the last one. We need this one to be 1, so we can divide it. So that's going to be R3. We change the R3 into the 1/2 of the R3. It's not going to be unique, this operation. You may use different format, but your row reduced echelon form would be unique. So this is it. We have 1010919. Okay, that's going to be 0135, and you divide, make it to the 001 and 2. You see that's going to be divided. You see, if you stop here, this is, you see what we got. It's a row echelon form. Now it's a row echelon form. You can apply this one in order to solve the problem. It takes a little bit more time. So if you stop here and use this one, so you're using the Gauss, okay? You are going to use the Gauss method. But if you continue making it to the reduced row echelon form, there's going to be Jordan method. So it's up to you. Which one do you want to use? So I go on to get it into the row reduced echelon form, or on the test. It doesn't matter. You can stop here, but I'm going to go on to make this into the zeros, and then that would be easier. So I have to get rid of this one. So this is going to be R2. So I'm going to have the R2 minus 3R3. So that we take care of this one. And this is going to be R1. I change it to the R1 minus 9R3. Quickly, that would give me lots of zeros, and then we can find the result right away. Okay, so it's going to be 1. This is it, R1 minus 9R3. So this is 1, this is 0. So that would disappear, because the 9, that given negative 9 and positive 9 would be 0. And over here I get the 18, and 19 minus 18 would be 1. Okay, and the second one, R2 minus 3R3. So that's a 0, that's a 1. So negative 3, that make it to the 0. Negative 6, so that would be a negative 1. Negative 1, and the last one would stay the same. You see, that is going to be the case. Okay, so as you can see, that matrix, you see this matrix was in a row echelon form. So if you stop with this one, you can solve the system using the Gauss method. Okay, so if you do it here, so you just apply the Gauss method. But this metric is in reduced row echelon form. So if you solve the system now, you're just using the Jordan method. Okay, so altogether, we appreciate the work of both of them. We go with the Jordan method. Okay, so now you know it. You can find it quickly, because that would represent the x, the y, the z, and the constant. Okay, so you read it from the system. Okay, you read it from this system is this is it. As you can see from the first one, 1x equal to 1, so x equal to 1. From the second one, 1y equal to the negative 1, so y would be negative 1. And from the last one, 1z is equal to 2, so z equal to 2. So the solution of the system, x, y, z, I'm sorry. Okay, x, y, z is simply equal to the 1, negative 1, and 2. So the system is independent, and you get one solution right away. Okay, not a big deal. You have many problems of this type, and we are going to give you one on this coming quiz and the first test. Okay, so the system was given, and we want to solve it using the elimination method. Elimination method, you work on the augmented matrix, change it to the reduced form, so that you'll be able to find the result. If you stay with the Gauss method, you see you have to do a little bit of operation yourself. So that gives z equal to 2. But over here, you have y plus 3z equal to the 5, then you have to substitute for the z. So it would be easier to, to get through it right away. Okay, so that's type 1. So there are going to be 3 types that it's going to be repeated over and over. Okay, so let's get the second type. So that was the first type. So what is going to be the second one? So the second one, we would like to solve this system. So this is going to be the given system. The system is x1 plus 4x2 minus 2x3 equal to 4. Okay, equal to 4. So the second one is 2x1. Okay, 2x1 plus 7x2 minus x3 is equal to the negative 2. And the last one is going to be 2x1 plus 9x2. Okay, 9x2 minus 7x3 equal to 1. Okay, so this is the system of the equation that we would like to solve. So form the augmented matrix again. So try to change it to the row echelon form and get your final answer. Okay, so the solution is going to be bring the augmented matrix. So this is it. It's going to be a three. You have 3 columns. You need 4 columns. One for the quotient, for the constant. So the coefficient of the first one, everything, all the variables are present. So 1, 4, negative 2, the coefficients, 1, 4, negative 2, and the constant term, which is equal to 4. In the second one, we get the 2. Okay, we get the 2, and we get the 7 and the negative 1, and you have a negative 2 here. And the third one, this is going to be 2, 9, negative 7, and 1. Okay, so this is going to be your augmented matrix. Remind yourself that this first one would represent the x1, the second one represent the x2, the x3, and the last one is your constant term. Just remind us that this is augmented matrix. Okay, there you are. So we are going to change it, reduce it. We already got the 1 here, so we have to take care of the 2 and the 2. Okay, so there you are. To get rid of this one, we need a negative 2, so we have the R2. We change it to the R2 minus 2R1. Okay, 2R1, because negative 2 positive 2 would be 0. At the same time, we can get rid of this one. We need a 0 here, same thing. So this is going to be R3. We replace the R3 by R3 minus 2R1 again. Okay, so quickly we take care of the first column. So the resultant matrix is going to be equivalent to the original one. So what we're going to have, the first one is going to be unchanged. We get the 1, 4, minus 2, or the negative 2 and 4. Okay, the second one, R2 minus 2R1. This is 2, 2R1, so that gives you 0. Okay, this is 7, 2, negative 8, so that gives you a negative 1. Okay, multiply this one by 2 and you subtract it. Okay, so that gives you, just check to see is all the form is given to you. Okay, so this is it. So 2R1, so that gives us a negative 1. Okay, negative 1, and then over here, negative 2R1, that's a positive 4, so that gives you a positive 3. 2R1, that gives you negative 8, so that makes it to the negative 10. Okay, so that's R2 minus 2R1. Then we go to the R3 minus 2R1, so that gives you 0. Okay, 9 minus 2R1, 9 minus 8, 9 minus 8, that gives you 1. Negative 7, 2R1, so that gives you a positive 4, so that gives us a negative 3 here, negative 3, and we have the R3 minus 2R1. Okay, so this is 1, 2R1, negative 8, that gives us a negative 7 here. Okay, so this is it. So we are done with the, okay, so we are done with the first column. Now we are going to take care of the second column. Okay, for the second column, this is a negative 1. It doesn't matter, you can multiply by a negative to make it into positive, okay, or you can switch these two, it doesn't matter. I'm going to switch it, so it's going to be R2. I switch it with R3. Okay, I switch these two, and then I can, I can make the other one 0, 2. So, you can do a number of the operation at the same time, and there are different choices. So I just stay with this one, and I continue. So I switch so that I have the one here. Okay, so this is it. This is 0, -1, 3, and the -10. Okay, so I got the one. I got the leading one. I have to make the others equal to the 0. So to make this one 0, so what I'm going to do, I'm going to change the R3 into the R3 plus R2. Okay, R2. And this would be interesting. You see, if you add them together, that gives you something interesting. So this would be 0. This would be 0, and this would be just a number. So if you just do it, you will find out that you are done. And that's the second type. So 1, 4, -2, and this is 4. So the next one is going to be 0, 1, -3, -7. If you add these two together, what's going to be the result? Is going to be 0. This would be 0. This would be 0. Okay. And that would be in -17. You see that? Give me -17. -17, you stop. You still look at this row to see what you have. Okay, so the conclusion of this row is, you see, 0 times x1, 0 times x2, 0 times x3, all of them would be 0, equal to the -17. Okay, so the conclusion of this row is going to be 0x1, 0x2, 0x3, equal to -17. So this means 0 equal to the -17. Okay, 0 equal to -17, never. So this system has no solution, and the system is inconsistent because get a 0 equal to the something. Okay, so there is no solution. There is no solution. There is no solution, and you can say that the system is inconsistent. Okay, one of them would be fine, no solution, or the system is going to be inconsistent. Okay, so that's the second case that is happen when we're solving the system of the equation, so don't be surprised. Okay, you double check all your operation, but you will end up with this one. You end up with this one that's all of them are 0. On the other side, we get -17. So 0 equal to -17, which is impossible. So there is no solution, and the system is inconsistent. Okay, so that's the second case. So the first case is nicely done. You try it, and you find one solution. So you know that the system would be independent because you get one solution. And in the second case, as you can see, there is no solution, and the system is inconsistent. Okay, so that's the second case. Okay, so that was a second case, and you have it in your assignment. Okay, so on the test, on the quiz, you suddenly get this type of operation. Don't be surprised, and that's it. There is no solution, and your system is going to be inconsistent. Okay, so that's going to be the second type of the example that we're going to have. Okay, so let's get to the third one. This third one is a little bit tricky. Okay, and this third one is going to be with us for some times. Okay, so let's see what is going to be the third one. You need to be patient to get through this third one. Not difficult. Okay, let's see what's special about this one. So the system that we would like to solve is going to be the following system. Okay, the system is x1. Okay, x1 minus 2x3 plus x4. Okay, plus x4 is equal to is equal to 6. So we have 4 variables. Okay, the second equation is going to be 2x1, 2x1 minus x2 minus x2 plus x3 plus x3 minus 3x4. 3x4 is equal to the 0. Okay, and the third equation is 9x1. Okay, 9x1 minus 3x2, 3x2 minus x3, and this is going to be minus 7x4, and this is equal to 4. So that's a system that we would like to solve. Okay, as you can see, this is a system of 3 equations, but 4 variables. So there is a possibility that this system is going to be dependent because the number of the equation is fewer than the number of the unknown. We have 4 unknown, so we usually need 4 equations. So you may get a dependent system. Okay, so let's try. When we get the dependent system, remember you are going to have infinitely many solutions. So let's try with this in mind. Okay, so we go on to get the solution. So the solution, get your augmented matrix. So this is going to be your A, which is going to be equal to, so bring the coefficients, x1, 2, 3. For the x1 we have 1. There is no x2, so it's going to be 0. Okay, the x3 is a negative 2, and the x4 is 1, and we have a constant term which is 6. Okay, that's it. The second one, the coefficient of the x1, 2, negative 1, 1, negative 3, and we have the 0. And the third one, this is a 9, negative 3, negative 1, negative 7, and 4. Okay, so this is all you have. And so remind yourself that, okay, if you want, remind yourself that that represent the x1, x2, x3. You don't have to, okay, but I just write it down so you know what's going on. And this is it. And so try to change it. Okay, try to reduce these metrics into your reduced echelon form. So on the first row, I need the leading one. You already got the one. So I have to get rid of these 2. Okay, make it 0. So that's the first action that I'm going to take. So this is going to be R2. I change the R2 into the R2 minus 2R1 to get rid of the 2. So that's going to be R3. I change the R3 into the R3 minus 9R1. Okay, 9, this is 9. 9R1, okay, to get the first column in order. And so this is going to be the leftover. Okay, so the leftover is going to be, this is going to be the matrix. So the first row is going to be unchanged. This is 1, 0, negative 2, 1, and 6. That's going to be the first row. So the second row, R2 minus 2, R1. So that makes this one into, okay, that makes this one into the 0. And the second one is just the 0. So that gives you a negative 1. Okay, R2, which is 1, and that gives you 4, which is 5. Okay, and this is, okay, this is going to be 6. Okay, so that's going to be a negative 6, then the negative 5, negative 5, and that is simply R2 minus 2 R1, so that gives you negative 12. Okay, so that would be a second row, R2 minus 2 R1, so R3 minus 9, so the 9, that give you 0. Okay, that give you 0. Okay, so the second one is going to be 9R1. This is just a negative 3. Okay, this is going to be negative 3. And the next one is going to be 17. Okay, 9R1. That is the R1. So it's positive 18, 17. and the next one that would be 9, negative 9, and negative 7 would be negative 16, negative 16, and over here we have what? We have a negative 54. Negative 54 and 4 would be negative 50. So that would be the resulted matrix. Okay, so R3 minus 9, 9 R1. Okay, so what we have so far, we are happy about the first column because we get the leading 1 and 0, 0. So the second, we are work on this one. This is a negative 1. So, we can change it quickly. We can change it by multiply by negative 1 if you like. If you multiply by negative 1, that gives you the result right away. Okay, so this is R2. I change it to the negative R2. Okay, negative R2. Then I'm going to have a positive one here. Okay, so as soon as I get a positive one, I have to get rid of, okay, this part. So what I'm going to do is, this is it. So I get the R3, I need a positive 3 here. So it's going to be R3 minus, okay, R3 minus 3R2. Okay, 3R2 because that make this one into 0. So the resultant matrix is going to be, this is it. So the first one is going to be unchanged, 1, 0, negative 2, and that give you 1 and 6. Switch a sign. So 0, 1, negative 5, positive 5, 12. Okay, now R3 minus 3R1. So what's going to be the result? This is it. This is it. We get a 0 here. Okay, 3R2, make this one into the 0. 3R2 is going to be negative 15. So that gives a positive 2. Okay, and 3, negative 3R2. So that would be a positive 15, and the 16, that can be a negative 1. Okay, negative 1. And then negative 3R2, that would be a positive 24. Okay, so this is it, 3R2. It's going to be positive 36. Okay, so that would give us 3R. I just double check, make sure I got it all right. Yes, that's fine. Okay, I'm just checking these numbers to see what I got here. Okay, so that's going to be 0, negative 2, and negative 1. So negative 3R2. So that is make it into, I just double check, make sure you get the correct one. That was the one. Negative 15, positive 2. So that's going to be 15, negative 1. So I have the negative R2. So that give me a positive 36. Okay, negative 3 times negative 12 would be positive 36. And 36 out of, okay, out of 50, that give me negative 14. That is going to be the final answer so far. Okay, I just double check because the one that I have in my, okay, this is it. So where do we get this negative 12? Okay, so we have the 0, 1, negative 1, 5, negative 5, negative 12, and that is a negative 50. So this is it. I switch it here, and then R3 minus 3. So that gives you 0. That's a positive 3. That's a negative 15. So negative 15 and 17 would be 2. So that would be positive 15, negative 1. And this is a negative 3 times a negative 12. That gives you 36. 36 out of 50 would be 14. Okay, that's fine. So what I did, we are fine with this part, 1, 0, 0, 1. So we have to take care of the, okay, we need a 1 here. So what I'm going to do is I'm going to divide this one by 2. Eventually we have to divide it. So why not just divide it now? So this is going to be R3. So I divided by 2, so that can be 1 R2. Okay, so that give me 1, then I can continue. Okay, so let's get, we try to avoid the fraction as long as it's possible. So otherwise this is going to be 0. It's a negative 1, 1, 6. Okay, and it's going to be 0, 1, negative 5, 5, 12. Okay, now I'll change this one. So it's going to be 0, 0. I got the 1. So this is going to be a negative 1. Okay, negative 1. And we divide it by 2. That gives me negative 7. So this is it. So what I have is 1, 0, 0. So I have to take care of these 2, which is going to be easy. Okay, I have to change this one into the 0. So I simply get the R2. So I get the R2, then I add 5 R3. Okay, that would take care of this one. And this is R1, and this is going to be R1. I just add 2R3. Okay, 2R3. So we continue. What's going to be the next step? So the next step is R1 to R3. So that give you, 1, 0. Okay, 2R3, that makes this one into the 0. And we have 2R3. So if you multiply this one by 2, that give you a negative 1, and 1 that gives us a 0. Okay, that would give us 0. Very nice. And here negative negative 14, so that gives us a negative 8. So that would be a negative 8. In the second one, R2 plus 5 R3, so that's going to be 0, 1, 1, 0, 5 R3, that gives me negative 5 half. Okay, so it's going to be negative 5 half. You want to add it to the 5. Negative 5 half is 2.5, so that gives you 5 half again here. Okay, the 5 half. And then over here, 5 R3, negative 35. Okay, it's going to be negative 35 and 12, which is going to be negative 23. Okay, so R2 minus 5 R3, so that gives me negative 35. Negative 35, 12 out, so that gives you negative 23. And the last one is going to be 0, 0, 0, 0, 1. Okay, 0, 0, 1. And this is going to be simply that the negative 1 half and the negative 7 that we have. Okay, so this is going to be a situation that we are going to have. As you can see, this is a row reduced echelon form, because this is 1, 0, 0, 0, 0. So that is the best we can go. So what we are going to do is we just, as you can see, this is going to be, the system would have infinitely many solutions. So if you translate what you have so far, remember that was the x1, x2, x3, x4. So the conclusion is going to be from the first one, you see from the first one, we get the x1 is equal to the negative 8. From the second one, this is x2, so we get 1 x2. That's the x3 and the x4. So 5x4 is equal to the negative 23. Okay, negative 23. And what's going to be this last one? X1, x2, x3. So that gives you x3 minus 1 half of the x4 is equal to the negative 7. So that's the best you can do. Okay, so the x1 is equal to the negative 8. So you have 3 more variables. You have to pick one of them to be free agent. Okay, because you have 4 variables but 3 equations. So what you're going to do is you are going to let, okay, So, for example, you let x4 to be equal to, okay, x4 is equal to the t. There is a 2 and the 2 here. If you like, you can call it 2t so that, you'll be able to simplify it. So that is going to be your x4, then enable you to be able to take care of, to take care of this. Okay, so if you just go one more step, as the step is going to be your x1 is equal to the -8. If you find the x2 would be -5/2 x4 minus 23, and the x3 would be 1/2, -1/2, all the positive. 1/2 of x to the 4th minus 7. Okay, you solve. Now you can substitute, because you have to pick the x4 to be 4t because you can't do it. So the x1 is equal to the -8. So that's going to be your x1. So x2 is equal to, you substitute, you see it's going to be -5/2, 5/2 times 2t minus 23. So the 2t would be simplified, we get a -5/2 minus 23. Okay, in the case of the x3 is going to be 1/2 times the 2t. If you like to reduce the fractions, so that give you t minus 7, and eventually x4 is equal to t, okay, for any number t. Okay, so the system is going to be dependent. The system is dependent, and you're going to have infinitely many solutions. So be careful. Sometimes it's a little bit messy when you get these type 3, okay, to get the dependent system. In this case, I change it, okay, then I couldn't go on. But sometimes the problem in your book, you get the last row to be 0, 0, 0, 0, then you will lose one row right away, and then you have to do the same thing over here. Okay, so that's going to be the third case. The third case is you are going to have fewer equation, if you like, in this case, and then the variables, and then you do your job, you change it. You see, this is the row reduced echelon form. Okay, you get the row reduced echelon form, then you have to check the free agent that you have. So one variable is going to be free. So I pick the x4 to be free. I call it 2t because I didn't like to have 5/2, 1/2. It doesn't matter. You can call it t and get those numbers, the same thing. Okay, so this is going to be the version. So as you can see in this problem, in these problems that we did, we have three cases, and we know that we have only three cases. The system would have one solution, no solution, or infinitely many solutions. So the system, uh, these are the possibilities. Now you have one more problem, one interesting one, and you get several of this problem, at least 4 in your assignment, and we usually give you one. Sometimes they give you a system. You see, they give you a system. They want you to give us a condition so that that system would have this result. Okay, there is going to be another parameter, if you like, into the system. So you want to impose some condition on that parameter so that the system would have one solution, two solution, or no solution. Are quite interesting problem and very important. Okay, so that would be the fourth problem that I talk about it. So I give you one. You have 3 in your assignment, and you get 1 in your practice one. Take on 1. So make sure you are able to handle these type of problems. Okay, so let's check one of them to see what I'm talking about. So that's number 4 that you have to know. Okay, so this is it. What is this one? You see, they ask you to determine the values of a number of the constant, let's say constant number A, constant number A, okay, for which the system, okay, for which the system has no solution, no solutions. That's one case. Exactly one solution, exactly one solution, okay, exactly one solution, or infinity many solution, infinitely many solutions. Okay, want to check the possibilities. So what's the system? This is the system. The system is x plus y, x plus y plus 7z, 7z equal to the negative 7. That's the first one. The second one is 2x plus 2x plus 3y plus 17z, 17z equal to the negative 16. That's the second one. And the third one, x plus 2y plus parentheses a squared plus 1 times z equal to the 3a. You see, you have a parameter a. So you want to arrange the a, okay, arrange the value of the a that give you these possibilities that we talk about it. Okay, you know that you solve the system, you may get one solution, no solution, or infinity many solution. So let's see what's going to be the situation that you are going to make a decision. So to solve this type of problems, you just continue the same method, okay, the method of solution, which means you're just working on the augmented matrix to see when or where you have to impose a subcondition on A to get the desired, okay, convolution, okay? So there you are, solution. Get the augmented matrix again, okay, this is it. So what's going to be augmented matrix? This is going to be A equal to the matrix. You have the x, y, z as the variable. It's going to be 1, okay, 1, 7, and this is a negative 7. That's the first one. You don't have to, just remind yourself that this is x, this is y, and this is z. So in the second part, we have 2, 3, 17, and the negative 16. That's the second row. And the third one, we have 1, we have 2, this is a squared plus 1, and we have the 3a. Okay, this is what we have. And remind you that this is just a constant term. Okay, continue, just as usual. We want to try to change it, okay, into the row echelon form. You already got the 1, so you have to get rid of this 2. Okay, get rid of this 2. So to get rid of the 2, so this is it, we get the R1, and this is going to be R1 minus, okay, minus, sorry, that's R2. That's R2, the second row. So we keep the second row and minus 2R1. 2R1, that gives a negative 2. And then you want to make this one 0. This is easy. It's going to be R3. You subtract that. It's going to be R3 minus R1. Okay, quickly we'll be able to take care of the first row, first column. So that's it. So the first one is as is. It's going to be 1, 1, 7, and this is a negative 7. R2 minus 2R1. So let's make this one into the 0. Okay, 2R1, 3 minus 2, which is going to be 1. 2R1, that gives a negative 14, make it into the 3. Okay, and 2R1, so that gives a positive 14, and it's going to be a negative 2. That's it. Then R3 minus R1, R3 minus R1, R3 minus R1, that gives you 0 here, minus R1, 2 minus 1, that gives you 1. Okay, and here R3 minus R1, this is A cube plus 1 minus, it's A square plus 1, which is going to be minus 7. And in the other side, it's going to be 3A minus R1 would be 3A plus 7. Okay, so this is what we are going to have. Now we simplify this part. Okay, we simplify this part, and that will give us what? That will give us A squared minus 6. Okay, A squared minus 6. So we are done with the first column. In the second column, we need the 1. This is the 1, so we have to get rid of these 2. Quickly, we can subtract to get it. To make this one into the 0, I'm going to get the R1. I change the R1 into the R1 minus R2. So that makes one into the 0. And to make this one into the 0, so this is going to be R3. So I get the R3 minus, okay, minus R2. Okay, so quickly you will get a desired form. So R1 minus R2, so that's going to be 1. 1 minus 2, that gives you 0. Okay, 7 minus 3. Okay, that gives you a 4. Again, this is it. 7 minus 2, 7 minus negative 2, that gives you a negative 5. Okay, negative 5. The second one is unchanged. It's going to be 0, 1, 3, and the negative 2. Now R3 minus R2. R3 minus R2. So that gives you 0, and that gives you 0. Okay, it's going to be 0, 0 now. R3 minus R2, we have A squared minus 6. It's A squared minus 6 and minus 3. Minus 3, and here you get the 3A plus 7 minus R2, which is going to be a positive 2. Okay, so if you simplify it, so that gives you 1, 0, 4, negative 5. In the second part, we get the 0, 1, 3, negative 2. And over here, you get the 0, 0. This is going to be A squared minus 9. And this is going to be 3A plus 9. So that gives you the system. Okay, now as you can see, you are in a, so we get almost in the reduced form. So we have to focus here, you see, to see what is going to be the situation that we are going to. You can argue here to get which of those possibilities are going to be. You see, you look at this one, and this is 0, 0. And this is, you have the 3 equations, 3 variables. So if you would like to have infinitely many solutions, the system must be dependent. The only way that's going to be dependent is going to be if both of them are 0. If both of them are going to be 0, then you get 0, 0, 0, 0. One row would be out. We get a dependent system, and you get infinitely many solutions. The way we are going to have 0, 0 is if these two would have a common factor. Okay, if you have a common factor. This is A squared minus 9. You see the A squared minus 9? You can change it to the A minus 3 times A plus 3. And if you factor the 3 out here, so that gives A plus 3. You see they have the same factor. So this means if you take A equal to negative 3, you see A equal to negative 3, we get 0, 0. So in that case, one line would be out. You have 3 equations and the 3 variables. So it's going to be one free agent. So in that case, the system would be dependent, okay? So it's always the case. We check to see if we get the 0, 0 here. So we are going to explain it, the possibilities. So the first one is you claim that if a is going to be equal to -3, then as we talk about it, a squared minus 9 would be equal to the 0, 3 squared minus 9, and 3a plus 9 is also equal to the 0. So we get the 0, 0, and the system is going to be dependent. And the system is dependent, and the system has infinitely many solutions. Infinitely many solutions. Many solutions. So that would be one possibilities. So to get to this one, just check to see if you have the common factor. So you have the common factor. So by that common factor, you get the 0, 0 all over the places. So this is where we get infinitely many solutions. Now, in order to get no solution, and this is going to be the case, you should have something impossible. That something impossible means this must be 0, but this must be a non-zero. Okay, 0 and the non-zero, just check. Check over here, okay? So to get the 0 and non-zero, the a squared minus 9 would be 0 when a equal to 3. If you put a equal to 3, this would be 0, but if you put a equal to 3, that gives you 18. So that would be the second possibilities. So the second possibility is you shouldn't have common solution, because if you get a common solution or a common factor, make both of them 0. So you need something that's not going to be common factor, and you can see that this is going to be a minus 2, 3. So you claim that if a is equal to 3, then a squared minus 9, it would be 0, because 3 squared, 9 minus 9. And or bet 3a plus 9 is not. That gives you 18. Okay, it's going to be equal to the 18, which is a non-zero. So we get a situation that this is going to be 0, 0, 0, but this is 18. This means 0 equal to the 18, which is impossible. Okay, so we get the 0 for the first one, but we get 18 for the second one. So this would be impossible. So the system, okay. So and then the system, okay, that's it. The system has no solution, because it would be impossible. Okay, so the system okay, the system has no solution. Okay, so we arrange it so that we get the 0 on one side of the equation, but we get the a non-zero number on the other side. So this is the situation that you are going to have no solutions. But when are going to have a solution? You see, if you go back and check, you have to exclude these possibilities. You can have a solution. Okay, so you know that this is going to be the coefficient of the x3. If this coefficient is a non-zero number, you always get one solution. Okay, it's going to be 2, 5. It doesn't matter whether this is 0 or not. So if you get, if you get a 5, 6, 7, that give you 5 x3 equal to the something, even if that something is 0. So you have to guarantee that this number is not going to be 0, because this is the coefficient of the x3 or the coefficient of the z. So this is going to be non-zero if a is not equal to 3 or a is not equal to the -3. Okay, so the third case, sometimes it may not be possible to have all of them, but in this problem it does. Okay, so if a not equal to positive -3 is not equal to 3, if you like, then I just remind you, then a squared minus 3 is not 0, and the system has one solution. And the system, okay, the system has a unique solution, one solution only, a unique, a unique solution. Okay, so because this is the coefficient of the third variable, okay, the third variable is z, or yes, in this case it's a z. So if you make this one non-zero, so this means the z won't disappear. It doesn't matter whatever it's going to be on the other side, you see. And so that gives you the system of the equation has a unique solution. Okay, it's a very important problem. As I told you, you get 4 in your book, 4 in your assignment, and we usually ask you to do one of them for us on the various. It's very nice argument really, and it's the best part of the example that you're going to have. Okay, so double check it. You have a couple of them in your assignment. Then if any question, you bring it in again. We can talk about it. So this is all you have to know from this section. So by the end of this week, as we can see, we covered the sections. Okay, we covered the section 1.1 and 1.2. So you should be able to solve the problems on this section. So we got the idea of the system of the equations. As you saw, it was easy to solve this system using a matrix. So what we're going to do in section 1.3, officially we are going to introduce matrices. So matrices, we bring them a matrices as a function, and we check the various properties of of a matrix. And then you will find out that there are two new methods to be able to solve a system of the equation. So then we come back. So make sure you know the name of this method. So the one that we did so far is elimination method. So on the test or the quiz, we give you the method, then you are going to operate it for us. Okay. So check the problems, everything so far by the end of this week, 1.1, 1.2. So for the coming weeks, we are going to prepare for that quiz. The quiz is going to be take on one. So I post it by next Friday. So you have a couple of days to think about it and bring it back. I post it and give you all the details. Okay. So by Monday, I will post another lecture for you, or the first lecture on section 1.3. Okay. So that's a target. Make sure that you are prepared and you've done everything so far. You have some tricky problems, and I post that practice quiz so you can see it and the type of problems that we are interested in. Okay, so there are some other definition in your book, but these are the one that we are going to be interested in. So something like 4 problems so far. Okay, I post this one right away. Any question, let me know. You can come to my office over, but send me an email in advance. I'll be around, okay? But send me an email, then I come back to the Zoom and we take care of it. The times that I give you Monday, Wednesday, and Tuesday, Thursday. Anything else, any other time, just let me know. Then we can arrange it. Okay. So try to get this 1.1 and 1.2 quickly over the weekend, so that by Monday you are going to be done with all these 2 sections. Okay. It's a heavy section. Not bad. It's just the beginning, but get over it quickly. Okay. Any question, let me know. Okay. Have a good one and take care. Bye-bye.